Hi everybody, welcome back to our channel EASI. Everything about semiconductor industry or everything that you need to know about semiconductor industry. So today we are going to talk about the semiconductor manufacturing process. So without any further ado, let's get started. So the question is, why semiconductors matter? Semiconductors are the materials that exhibit intermediate electrical conductivity, lying between conductors like metals and the insulators on the other hand like rubbers. Thus, it allows them to control electrical currents effectively. Semiconductors are fundamental in today's technology, enabling the functionality of over 90% of modern electronic devices. From smartphones to the computers, these materials drive innovation and connectivity, making them essential component for our daily lives. Now, let us talk about the process flow. The entire process flow starts with crystal growth, where pure silicon crystals are grown and then the solidified crystals are sliced into wafers which are to be used for further processing. Then several patterning cycles including litho, etch, depositions are performed, and then the completed wafers are inspected to ensure quality and functionality. After that, the chips are prepared for packaging, which involves testing, ensuring proper electrical connections and reliability. Now, let us go over each of these process steps one by one. So first, let's talk about the silicon crystal growth. Wafers are sliced from silicon ingots. Ingots are the purified silicon crystal. Purification of silicon is essential for high quality wafers, enabling optimal performance in semiconductor device. Once the wafer is sliced from a purified silicon ingot, now it's time for the patterning process. Now, the patterning cycle can be broadly differentiated into different modules, namely litho, etch, doping, and thin film deposition. Now, let us elaborate on each of the patterning steps. So, the first comes the photolithography. As the name suggests, it is the exposure of the wafer to litho or light. So, photolitho process steps can be explained as follows. First, photoresist is applied to the silicon wafer. Then, it is aligned such that it can be properly exposed to the UV light. Then, the pattern is developed on the wafer. Inspection for accuracy and defects are performed so that it is ready for the next manufacturing step. So once the pattern is developed onto the photoresist, now it's time for etch. Etching is the process of selectively removing material from the wafer surface. This is crucial for defining circuit patterns and ensuring the precise formation of the electronic components on the chip. Etching can be dry or wet etch with functionality varying between directional to isotropic. After that, doping is performed. Doping involves introducing specific impurities into semiconductor to alter its electrical properties, such that it enhances the conductivity. This process is essential for creating P-type and N-type semiconductors respectively. We talked about removing material from the silicon wafer through etching. Now let's talk about how a new material is added to the silicon wafer. So that process is called thin film deposition. Thin film deposition focuses on creating uniform layers on silicon wafers. Deposition can be of insulating or conducting material, and broadly there are two types of deposition process, namely CVD or the chemical vapor deposition, or PVD called the physical vapor deposition. All the modules that we talked about so far are used to perform the layering. Layering process is crucial in semiconductor manufacturing. It allows the deposition of materials such as oxides and metals to create transistors and electronic connections within the integrated circuit. Once all the patterning cycles are completed, then wafers are sent for testing and packaging. Final testing is crucial for verifying that the chips are meeting all the specs, ensuring reliability and performance for end users in various applications. Packaged chips ensure safety and functionality, providing essential electrical connections for efficient operation in various applications. There are broadly two different types of packaging, namely wire bonding and the flip chip. However, there are quite a few innovations are going on in this field in recent times. With that, we have come to the end of our today's session. In the following videos, we will cover each of these topics in depth to provide you a comprehensive knowledge of this field. So stay tuned. Till then, stay safe, stay healthy, and take care.